Welcome to the channel. I'm Dan Lee and I'm currently building a quarter scale version of a boat called Temptress, which is what you see here, and I'm sure you've heard me say that many times already if you're already following this series. In this video we're going to take a look at the shear clamp, which is the timber which runs along the top edge of the boat here along the shear line, and that carries the side planking of the boat and the deck planking as well. So let's take a look at what's going on with that. Okay, so drawing number 8, page number 8, gives us a look at our shear clamp and topside battens. So what we've already installed in the boat is the chine top rail, which you can see here. So we did that before we put our chine lamination into place. So we've also got to do our topside battens, which you can see here, and then the shear clamp, which is this top timber here, which runs along the shear line of the boat. And we can see a cross section of what that timber looks like here. But this is probably one of the more complex of the sort of longitudinal timbers within this boat. So as I say, we've done the top rail already, we've got to do the topside battens. And if you remember from when we installed the chine top rail, these timbers float outside of the framework, so we've got to install them so that they match that gapping that we did on the chine top rail. But let's take a look at the shear clamp first. So shear line is supported by the shear clamp timber. Depending on timber species, this may need to be laminated. So this is quite a thick square section timber, and depending on what type of timber you decide to use for this, you may need to make this up out of smaller sections, and that could be divided up in a number of ways. So let's take a little look at how that is going to pan out. Okay, so you might remember from the chine top rail when we installed that there are a couple of different ways that you can install these timbers to follow the two different curvatures that are going on with the bottom and the side of the boat. And we used this little tool here, if you remember, to work out our cutouts through the frames. And that created our little offset just to float the frame with that little spacer there. So we looked at that with the respect that it can either go in this plane and follow the curvature of the side of the boat, or it could go in this plane and follow the curvature of the deck of the boat. So we can effectively position that timber two different potential ways around. Now when we get to the shear clamp, there is quite a bit more twist going on within this boat. So we've got the top sides that are kind of curving out in this direction as they meet the deck up forward, and then as we get back aft, we've got the tumble home of the boat. So the top sides are coming in as the deck's coming round to meet it. So there's quite a lot of twist in this timber, and it's doing various things throughout the length of the boat. That's why this makes this a bit more of a complicated timber to think about. Now this is just a piece of scrap timber, but it's going to help me to illustrate the various different ways that this could be approached. So we're curving this timber in this direction in because it's going to meet into the stem. Now if you imagine that that timber is set vertically, so with our little marker piece, you imagine it's set in this plane, that would mean that we'd be beveling the bottom side, and then we'd be aligning the top side with the curvature of our deck line. If we do that, the timber's going to curve in really quite nicely, and it's going to follow, you can see, the tops of all of these frames, and it's going to meet into our stem, which will work quite nicely. But you can also see that if we did the timber that way, you're going to end up with quite a wide timber, because this has got to be right inside of this frame here. I'll do it on the forward side so you can see. So if that was in the vertical plane, that's going to have to come right in to there. So on the full size boat, that would probably end up being a timber that was, I don't know, maybe 70 mil wide by around about 80mm high. That's a pretty big timber and fairly wasteful. That's not really the way we want to do that. The good thing is that that will bend nicely in that direction. Very little edge set on the timber because the shear line is fairly straight, and the edge set is the curvature in this that snapped. The edge set is the curvature of the timber in this direction, which across its widest part, so it's a bit more reluctant to do, hence why that snapped. Now if we're doing a timber in that way, very little edge set on that timber, so it's going to curve in quite nicely. Now if we do the timber the other direction, which is over to match the angle of the side planking, that's going to be a lot more efficient use of the timber because it's going to follow this curve in. But what we're going to be ending up doing with that timber is putting quite a lot of stress on it. And as you can see, when this timber is over at that direction, as it wants to bend round inwards to curve towards the stem, it also needs to bend sideways, and you're going to be putting a huge amount of this edge set curve onto it. So basically this timber is happy to bend in that direction, but if we install it in the boat the second way, it's got to bend in this direction, and it's got to bend along its widest edge by quite a lot. And some boats that use this process, they use a huge amount of curvature and force on this timber. Boats such as the Chris Crafts used to do this, and they'd steam bend big oak timbers in with massive amounts of edge set on them. So it's quite a difficult timber to form. So we've got two options here really. We can either install this timber vertically, which is going to massively help us to curve this in towards the stem, but it's going to make the timber a very large section and really quite wasteful. Or we can match this to our contour of our side planking, but that's going to give us this issue that as we bend this inwards, as you can see, it also needs to come sideways or upwards. So we're going to have a little think about the way that we section this timber, and we're going to break it down into smaller elements. As I said, with some older boat designs, this timber would have been steam bent, and that would allow you to pull that edge set in and shape the timber. With these modern wooden constructions, I do not really recommend utilizing steam bending. I prefer to go down the line of lamination. So the basic premise with any of these modern wooden boat designs is that nothing should need steam bending. If it's too much of a bend to make with a timber cold, then we should be sectioning that down into smaller pieces and laminating it instead. So that's what we're going to have to do with the shear clamp. We're going to have to make up this timber out of smaller sections, and we're going to have to laminate it to get it to form that curve. Gives a much more stable timber and a much stronger timber in the long run as well. So what we're going to do is we'll just have a quick look in the 3D model on the computer, and we'll take a look at what this shear clamp timber is doing down the full length of the boat, because we've sort of seen how things are going to affect up here forward, but that's also going to change back aft on the timber as well. So let's jump on the computer and we'll have a quick look at that. So here is our shear clamp timber. This is the timber that we're talking about installing, and you can see how that changes down the length of the boat. So you can see that up forward here we've got a really severe twist as it follows this flare of the top sides, and then as we come back aft, that gradually settles out and reduces to match into the tumble home that we've got right back at the transom. So let's do a section analysis, which allows us to just chop through the boat at various different stages, and we'll take a look at what's going on. So right up forward here, you can see that this timber is actually quite small on its inside section, and you can see that we've got our two perpendicular edges here of the bottom face and the side face of that timber. So we're matching the side curvature of our frames, and then our bottom face is perpendicular to that. So that ends up with quite a small face on the inside, and then our bevel is cut on the top side, which is our deck line up here. Now the main focus with sort of positioning this timber really is to maintain this outer face here between these two edges at the same distance. so that we've got the same size timber all the way down the length of the boat, which is going to carry our side planking. So as you can see up forward, that means that this internal face here ends up quite small. But let's pull our section analysis a bit further back aft and we'll see how that changes. So you can see how that timber evolves as we drag the analysis through the boat. And let's take a look at it just after frame 9. So you can see that in this vicinity of the boat, the timber's looking a bit more square or rectangular, I suppose. So again, we've still got around about the same distance, surface area between our top and bottom edges on the outer face of this timber. And you can see that our internal face is now starting to get just a little bit wider than the outer face, and that is just as we curve back the opposite direction and follow the line of this tumble home in the aft section of the boat. So let's go right back to the transom. And now you can see again, same surface area on the outside of the shear clamp, but when we get to the inside, this is quite a large timber now, and that is quite a wide section. If we measure that edge, that is 82 millimeters wide. So the size of the timber that's given on the materials list is its largest section, which is right back here where we go through the transom. But as you've seen, when we come up forward in the boat, that turns into quite a smaller timber. So we've got to come up with a way that we can form this timber and get the twist in and basically arrive at around about the same surface width for the shear clamp all the way along the outer face, which is what I've got highlighted there. So with that in mind, let's jump back out to the model and we'll start cutting some notches in our frames to receive this timber. Okay, so with that in mind, I have myself another little timber marking device made up. So let's take a look at what's going on with that. So this will help us to mark out the notches for the shear clamp in the same way that we did with the chine top rail. So the width of this timber here is the width of our full height that we need right back at the transom. The width of this little overhang section here is the width of the constant face that we need to maintain on the outer edge of the shear clamp. And then this little shim here is our offset for our distance that this shear clamp wants to float away from our side framing. So we've got enough distance here to mark out our width right back down at the transom, and then this is going to give our constant height throughout all the frames. So let's try that on some frames and see what happens. Okay, so we put this timber up against our side frame, and you can see that this little shim here is just positioning that off away from the side of the framing there by the correct distance for our floating frames. This is the size, the largest size of our shear clamp, which is going to be projected onto the back, and then this height here gives us our finished face of the shear clamp that we actually want. So we can put that up against our side frame, and then we can run it up until this face here meets with the top corner of our where our shear clamp is going to sit on the top of our frame. And then once we hold that in position, if we mark the back edge, that is going to give us the size of the cutout for our shear clamp at that position. So that's frame 2. Let's take a look at some of the other frames further aft and see how that differs. So we'll look at that on frame 10, which is around the section in the boat where this is starting to get a little bit more square, this timber. And again, we'll put that up, position that in line with the side frame. We'll slide that down until this little cutout here meets the top section of our frame, and then we can use this back section timber here to mark the shape of our notch. And you can see now that's a much squarer notch than right up forward on frame 2. So we'll do the transom as well. Okay, so if you remember back to when we made the transom laminations, we've got some oversized timbers here. So we've got our correctly sized lamination on the inside, and our laminations on the outside are oversized. So we need to use this internal one as our guidance marker, which follows on through and up to the top bow of the transom. So that's the one that we want to use. This is oversized at the moment, wider than it needs to be, so we'll bevel this off and take these laminations down. So that is our guidance for size, so we're going to butt up against that and then run our timber in there. Okay, so let's look down the boat. That you can see our one on the transom there, quite large width on the internal face. We've got our correct width on the external face. Come forward to frame 10 and we've got an almost square section notch there with the internal face just slightly bigger than the external one. We go right forward to frame 2 and you can see that our internal face is much smaller than our external one, and we're at that sharp angle as we account for the flare in the top sides. Okay, so I have a batten pinned along the cutouts that I've marked for the shear clamp, and a couple of functions to that really. We're marking that out on what's called the control side of the frames. So these cutouts are going to be beveled as this timber comes in and curves in towards the stem, which means that we want to mark these on the aft side of the frame, because on the forward side of the frame they're going to be further forwards and there's going to be a difference in that cutout on the other side. So we're going to use this timber to start to try and get us that information, and obviously the run of this timber through the frame is going to be beveled in two directions. So it's coming through the frame at an angle here, and then it's also coming through the frame at an angle in this direction. So there's a few things going on, and that varies throughout the boat. So the function of pinning this batten on here is that it allows us to project that line forwards. So you can see that I've done marked the notch cut out on the aft side of the frame, and then I've just taken it round this corner here so that there's just a little bit of that line on this face, and then that's what I've aligned this batten to, which now that I've got the batten here, that's going to allow me to transpose that line forward and follow the true path of the timber in this direction, so we can project all of those through. And that is going to be especially helpful around frame 9. If you remember that frame 9 is our angled frame, because this is the forward end of the engine compartment and the back of the rear seat in the cockpit. So this is an angled frame, and it means that this cutout is obviously vastly different to the other one. So what I actually did was I didn't mark the notch on frame 9, and I'm just going to pick it up from this batten, which can run a nice true fair line between the frames either side of it. So we can pull in that line there on frame 9, and then you can see that that really sweeps up through these aft frames as the shear line drops off towards the transom. So a couple of functions to this timber. It's allowing me to transpose those lines and draw a good fair curve all the way down the edges of the frames for this notch. It's also allowing me to just check for fairness, so I can sight down this and I can see what the line of my shear line's looking like. So I can at this stage start to pick out any errors. So if I've got a frame that's a little bit high or a bit low and it's putting a kick in this shear line, I can choose what to do with that. I can either get to the bottom of why it's out, or I can omit it from, you know, sort of override its cutout. So think, okay, that cutout, despite the fact it seems correct, it's creating an unfair curve, so we'll leave that one out and we can make corrections at that stage. So we're transposing those lines across, we're potentially taking out any errors, and we're just checking for the nice fair curve down the length of that. And we've also got an opportunity to start trying to size this timber and see what might take the twist and take the curve nicely. So we want to use something that's going to fare well, so not too thin a batten that's going to end up all bumpy and wavy. We want something fairly stiff so that it's going to get a nice curve throughout the whole boat, but also something that's not going to be too thick, which, as you can see, this one is, and this is why it broke when I was trying to spring that into the stem there. Now, I tried a few different size timbers for this, and some square ones and some rectangular different section ones to see how they would make the curve. The good thing with a square section timber is that it's going to bend in both planes equally at the same time, so it's going to be really nice to pull in. And I think when we actually size the shear clamp for this, we'll end up with a collection of square section timbers for that reason. Now this is 8.5mm square, so if that was to scale up for the full-size boat, that's going to be a timber which is 34mm square section, and that would be way too big to be making these sorts of curves. So that kind of shows you why this is snapped here. It's a bit big for the scale really, but it is going to give me a really nice fair curve in the aft section of the boat. So I'm going to need something slightly smaller and thinner just to get that curve in up in the forward sections. But as you can see, this is a bit of a test run to sort of see how the timber is going to make the bend, get those lines through, and check that everything's fair as well. Okay, so we've got our notch cut out marked on the aft side of the frame. We've used this temporary batten to transpose that line through to the forward side of the frame, accounting for the travel through the frame in this direction for the shear clamp timber. But what we could also get from this is the size of our notch on the forward side of the frame. Now in the middle of the boat, this is going to be pretty similar. You can see that angle it's coming through the frame at. It's going to be pretty similar on the forward and aft side of the frames, but as we get up forward in the boat, you can see the difference in those angles there. So the notch on the forward side of the frame is going to be significantly further forward. Now whilst we've got a timber sprung in this curve, we might as well make use of that to mark those bits of information onto our frames. So I'm just going to use a little bit of scrap timber here that I've sized to match the notch on the aft side of the frame. Okay, so there we go, notch is marked through the frames, and you can see that we've now got that line transposed around every side of the frame for the true fall of that shear clamp. Okay, so you can see I've started to get an inner timber placed on the shear clamp. Now I think I'm probably going to make this up out of 4 timbers. So as I mentioned, working with square section timbers is really nice in this respect, and it allows them to curve in 2 different directions at the same time. So I think that's what I'm going to do, is build this shear clamp up out of square section timbers. And the benefit of that as well is that we don't have to dimension the shear clamp at its full size all the way throughout the boat. So right back aft, where we need that 80mm height in the full timber section, we're not going to need that forward, so we're not going to have to laminate all of those timbers up here. We're only going to need to place them where we need them. But I think what I'm going to do is start by placing this innermost timber, and then we'll use that to build the other laminations on top of it. But I'm going to have a little play around with things anyway. I want to make sure that this is a really good fair curve, and there's quite a bit of time in that, just making little adjustments to these notches and cutouts, sighting down that timber and making sure that it's good in all planes. I really want to get that right because it's a very key line of the boat. It's going to have a big effect on the way it looks, and I want it to be correct. So I'm going to fettle around with that over the next week, and then we'll revisit this in the next video. You can also see that I've roughly placed a topside batten, and we'll be looking at those in the next video as well. So we'll be equally spacing these between the shear clamp and the chine top rail, and we'll be getting those in place. I've just placed that at the moment because that's helping me to sight down against the shear clamp and just check that everything's fair. Having references there for those curves is really helping, and it's nice because it helps to start to show what the side of the boat might look like as well. So that's going to be quite a cool stage to get to. It's going to look more boat-like every step of the way. So initial dry fit of the shear clamp and one of the topside battens. We'll leave it at that for this week, and I'll carry on fettling, get that nice and fair and perfect so I'm happy with it, and then we'll carry on with some other stuff next week. So hope you enjoyed the video, and I'll catch you in the next one. Cheers guys.